Alright guys, so now we're going over to the Allen Bradley PLC. So if you've watched the Tweedo Suite PLCs, I'm using the exact same board as before. I've just switched it out for an Allen Bradley Micrologix 1200. If you're just coming onto this playlist, then this board has a number of different components here. So I've got a number of push buttons here, so two stop-start stations, a couple limit switches that we'll make use of. I got a 24 volt power supply here, which just takes the 120 and changes it to 24 volts DC. Here is my Allen Bradley Micrologix 1200. Beside it, I have an analog card, a couple indicator lights on the side here, and then below I have my control transformer to go from 120 volts to 24 volts AC, because all of these contactors below run off of 24 volts AC. So I have a forward reverse contactor with an overload and a couple other starters with an overload on one of them as well. Okay, let's take a look at the Micrologix 1200. So this guy right here is very similar to the Tweedo Suite that we were looking at earlier. Just in North America, Allen Bradley has a large market share. So in the Southern Hemisphere, Schneider has a large market share, as well as Siemens. In North America, it's primarily, at this point, Siemens and Allen Bradley. Anything to do with the car plants has Allen Bradley. So we'll be covering these guys for the next little bit. This one has 24 volts DC available. You get that 24 volts DC when you put 120 to it. So 120 volts on the bottom here. Usually there's a protective cover here. I've just opened this up just so I can jumper out some of my inputs and outputs to troubleshoot some stuff. So, but 120 on the bottom here, there's a rectifier circuit that provides us with 24 volts DC. You don't want to be powering up too many things off of that 24 volt DC. If you need additional things powered up, I would have a separate 24 volt DC supply. Okay, so these are all of my inputs. On the top, I have, let's see, 13 inputs on the top. And they're all, I've created them all as sourcing inputs, in that the positive voltage is going out to all of my switches, and the positive voltage going back to all my inputs, and I have jumpered the negative to the common. So all of my commons are jumpered back to the negative in order to complete my DC circuit. Okay, on the back end here are my outputs. They're running off of 24 volts AC. And the 24 volts AC is coming from, let me just pan down here, it's coming from my transformer here. So I have a 100 VA transformer down here that's going from 120 volts on the top to 24 volts AC on the bottom. Okay, they are relay outputs on the output side. You can have transistor, you can have relay outputs. These ones are relay outputs. Okay, again, I have jumpered my common to my 24 volts AC. Sorry, I had a stroke there. I forgot what I was saying. I've jumpered all my commons together here. They are now feeding out to my outputs through the output terminal. So each output terminal is going out to my output, and the return is coming back here to the PLC. Okay, aside from that, I have an RS232 link here. So I have a serial cable that I'm going to be talking to this PLC with. And then beside, I'm going to have to do my I/O configuration every time that I download a program, because in addition to the digital inputs and outputs, I also have an analog card here, and this just ties into this kind of printer cable here into the main PLC. So I have a number of different analog input and outputs. Looks like I have I got two inputs, two analog inputs, and two analog outputs. And again, you can do 0 to 10 volts, or you can do 4 to 20 on those bad boys. Okay, now that you've taken a look at the PLC and you've kind of got an idea of where the inputs and the outputs are, then the next thing to do would be to get your PLC talking to your computer. So let me go through the steps on how to set up the RSLinx next. So let's pan off to the computer and we'll talk about that now. Okay, so just so everybody's cool on how I've wired this guy up, I have the 24 volts positive supply going out, and that's going to feed all of my switches. So I have a normally closed switch for my stop, I have a normally open switch for my start, I'm going to make use of my motor holding contact, which is a normally open contact, and I'm also going to make use of the normally open on the overload. Okay, on the output side, I have a 120 to 24 volt transformer. I have a 1 amp fuse going to my COM, and then from there, from my outputs, I'm going out to my motor contactor, through my normally closed contact, and back to X2. Again, this usually screws people up. I have the normally closed on the output side. That's going to open on the case of an overload. But to send a signal into the PLC, I have a normally open over here. So I have 24 volts DC on these two terminals right here. And I have 24 volts AC on these two terminals here. Okay, everything stays the same. So if you've seen the Tweedo PLC video on this 3-wire, then everything stays the same. The only thing that changes is the addresses. So for here, I've got input : 0/0. So here I've got input : 0/0. And that corresponds to my Allen Bradley. Okay, so all of the addresses I have right now correspond to the Tweedo suite, but I'm going to erase those and replace them with my Allen Bradley addresses. So the next one here for my start is written like this. I have input : 0/1. So remember, everything starts at 0 and then moves up from there. Okay, this guy right here for my motor holding contact, well, that's going to be input : 0/8. Okay, and we'll just keep going for the outputs. The outputs are labeled the same way. Just instead of having that Q there for the output, they have an O in the front there. So the address for the output is 0:0. So output : 0/0. Okay, so I've addressed everything there, and then I'll just change everything below to match. Okay, so let's just, I have everything written in a blue, so we'll keep going with that. So each of these guys, instead of being %I or %Q, then it just turns into input. So for this guy, I have input. It's on the first word, and it is the first bit of information that I'm looking at. Here for the start, I've got my input. Again, first word, but I'm looking at the second bit of information. Easy now. Okay, and then this motor contactor I have at input : 0/8. And the overload, where I have the overload? The overload is input 0/9. Okay, so just changing all these guys. Let me just pause the video and I'll change everything right across to match with the Allen Bradley PLC. Okay, so everything across. One thing I noticed was that I had the address wrong for my motor contactor. I have my motor contactor actually tied into output 9. So I have output : 0/9. And again, I'm just addressing this guy over here so that all my appropriate addresses are everywhere along. Okay, this guy here is a normally closed. So this XIC is looking for voltage. If nobody's pressed that stop push button, then that voltage is clearly at that input terminal. So I'm looking for the presence of voltage. I'm also looking for the presence of voltage at the start push button. Because when I press that start push button, then that voltage will travel from here over to my input terminal. So I'm going to use an XIC and examine for when there is voltage at that input terminal number 1. Okay, my motor contactor, well, when this contactor turns on, this contact will close, and again, it'll allow that 24 volts to go to my input number 8. So I'm examining when it closes and when there is voltage at this input. Okay, this overload, I do not want to be in an overload state. So I have made use of the normally open contact, and if I haven't had an overload, then this stays in the open state, meaning that the 24 volts will be available right here, but it won't be transferred to the input number 9. So I'm going to use an examine if open. I'm examining that this is still open, or I'm examining that this is a 0, or that no voltage has been applied to the input. If everything's true right across, I'm going to turn on my motor contactor. And again, when my motor contactor turns on, this will close, and it'll provide another path of logic to keep that bad boy turned on. Okay, over here I've provided with 24 volts AC to my common. So there's 24 volts AC available for whenever these relays in the PLC turn on. So when output 9 turns on, that 24 volts will go out in the field. I'll have 24 volts in my coil. My contactor will turn on, and as long as I'm not in an overload state, it will stay on. Alright guys, let's take a look at our programming now. Okay, so what I'll do is I'll make this portion a separate video as well. So if you're lost and you can't forget the initial configuration of the PLC, you can always go back to the other video and you don't have to walk through everything that I'm doing here with the 3-wire. But in order to talk to the PLC, we have to turn on this driver manager right here, this RSLinx Classic. So you have two programs that you're going to run. You're going to run this RSLinx Classic. That's going to allow your computer to talk to the PLC, regardless of which Allen Bradley PLC you're using. And you're going to make use of the RSLogix 500 to do your actual programming. So first step is to open up this bad boy right here. If you have a desktop item, it'll be here. If you go to your start, then it will be in your start menu as well if you want. Or you can go to all programs and find it. Okay, so let's open up that RSLinx. Excellent. Okay, so the first thing we need to do is to go here. We need to configure the drivers. So we're going to click on this guy. Now I already have this guy running. Let me delete this guy and we'll drop in a new driver. So what I'm using here is an RS232 serial cable, right? So I'm going to make use of this, the RS232 DF1 devices, and I'm going to add a new one. So this guy right there, I'm going to add a new one. Sure, that's a good name for it. You can rename it if you want. It's already chosen COM port 1, so you can see that there. And we're going to do auto configure now. Okay, so it's going out, testing everything out. And then once everything's cool, it should say that everything's all right to go. Interesting. Okay, let's try it one more time. You know what's wrong? I don't have the PLC on. Give me 2 seconds. Let me put power to the PLC. Because obviously, if you don't have the PLC on, then you can't auto configure. Hang on 2 seconds. Alright, let's see if I got it. What a donkey. Let's see if this works now. Auto configure, my PLC is up and running. Hey, auto configure successful. Yes, turn it on, my friend. Okay, so once your PLC is on, you'll be able to auto configure and everything should work smooth. Okay, we'll hit OK. Everything's running now, so we're good to go. Next thing to do is to go over here. So again, I went to here to configure my drivers. I'm going to close this guy up. I'm going to go over here, and I'm going to go to RSHU, and I'm going to open this guy up. Okay, so right now I can see there's my AB Allen Bradley DF1.1, and right now you can see there's my workstation, that's my computer, and there is my Micrologix 1200 PLC that I have hooked up to it. Beautiful. Okay, so everything looks like everything's rocking and rolling now. Okay. So let's see if we can talk to our PLC now. So what we'll do is we'll just close this guy up. We'll minimize this guy. Okay. And then let's bring up our RSLogix 500. Okay. Let's make this larger so we can see what we're doing. Okay, first thing we're going to do is we're going to create a new PLC program. So we're going to go here to New. The PLC that I am using right now is a Micrologix 1200 Series C. Okay, so I'm going to click on this guy and hit OK. Beautiful. As soon as you do that, then all of your file folders open up here, and your LAD2, this is the main portion where you're going to put the program in. Now I have one more thing I need to do before I start programming. I want to go over here to IO configuration. The reason why I want to do this is because I have an analog card that is connected into my Micrologix 1200. Sorry guys, I lose my voice today. So what I need to do is I need to hit read IO, and that's going to go out and tone and see what else is connected into my PLC. So I'm going to hit read IO. I can hit who's active and see who's on there. But what I'm going to do is I'm just going to go here and read IO and do the configuration. Ah yes, there's my analog 2-channel input, 2-channel output. If I don't do this, then when I download a program, I'm going to have a red fault light coming and flashing on my PLC. So it's crucial that you tell the program exactly what's connected to your PLC. If you don't have an analog card connected in, well, you don't have to do this IO configuration. But in our shop, we do. So if you're wondering why the red light is flashing at you, you have forgotten to do your read IO. Okay, everything's cool now. So now what I'm going to do is I'm going to drop in that same program that we looked at before. So I'm going to grab this line right here, and I'm going to drop in an examine if closed. So this is very similar or exactly the same as the Tweedo suite. But look at this. I'm hovering over this, and no green lights are turning on. So let's let it go. Let's highlight that rung, and then we can bring this guy down, and we can drop it in. Still nothing happening. So what's going on? Well, maybe we need to add a rung, because this last line right here is the end of our program, right? So let's add a rung here, and then let's try the same thing. Let's drop in and examine if, there we go. Okay, so we can't drop it in here. This line is just for the end of the program. Okay, we're going to drop in examine if closed for the stop, and examine if closed for the start. I need an output. Excellent. I'm going to have an examine if open for my overload. And then around this bad boy right here, I need to put a parallel rung here. So I'm going to hit here and put rung branch. And isn't that annoying? It puts it over here where you do not want it. So you're going to left click with the mouse. You're going to drag that bad boy over until you see a green, and then it'll be in parallel. Now, I would move this over because that's not going to work for us. Let's try. Let's see what happens if I put an examine if closed there. Okay, it puts it in a completely wrong place, right? So a little bit annoying when that happens. Let's just get rid of this guy. Where's the delete here? Give me 2 seconds. Let me find my delete. Okay, so now what we need to do is we're going to highlight here on the left-hand side of our parallel rung, and we're going to drop in an examine if closed for our holding contact. Excellent. Okay, and that's everything that we had on the previous page when we were going through all of our wiring. Now the inputs here, you can physically tap on this guy, so you can double tap. Here we go. And you can change the instruction type, right? You can address this as well, right here. But I like going and opening up my input IO. So I'm going to open up my data table here. And here you can see that the first word is going to be used. So I have input 0.0, right? And then each of these guys are my bits 0 through 15, giving me my 16 bits for my word. Now, we said that the stop push button was going to be input 0/0. So we're going to grab this bit of information, and I'm going to left click on it and drag that bad boy up. There we go. Okay, so there's my stop push button. If I wanted to name this guy, then I can name this as my stop push button. Okay, and I can say in the description that I have a normally closed contact. Beautiful. Okay, the next guy is going to be my start push button. So in the symbol here, I'm going to type in start push button. Easy now, come on. Okay, and I know that this guy is a normally open contact. And again, what I'm going to do is I'm going to grab this guy and bring this guy up to here. Beautiful. Okay, I have two other inputs. I have to make use of input number 8, and input number 8 is going to be my motor contact or holding contact. Okay, and I made use of a normally open contact. You don't have to put all this in here, but it helps to have a little bit more information. And then input number 9 is my overload. Okay, and this guy was a normally open contact. Beautiful. Okay, so now that I've labeled 8 and 9, I'll show you another trick. So instead of using this data file here, you can come down here, and as long as you have labeled each of your inputs or outputs, you can go down here to Symbol Picker, open this guy up, and there's all of the inputs that I have now labeled. So there's my overload contact. So I can grab this guy and bring it up here until I see green. And then I've got my motor contact or holding contact. I can bring this guy and drag it over, or I can grab that input number 8, right, this guy right here, and I can grab this guy and bring it up as well. Okay, so there's a number of ways that you can address each of your units. Okay, so that's all my inputs. Now I need to make use of one output, so I'm going to open up my output data table. My output for my motor contactor is physically wired to output number 9. Can't spell today. Okay, and my motor contactor is there. Looks good. So we'll hit enter. Everything's ready to rock and roll. I'm going to grab this guy, bring it over, and drop it in. Sweet. Okay, so now I have my examine if closed, examine if closed, examine if open, turning on my motor contactor, and I've got the actual holding contact that's going to pull in, and that holding contact was wired to input number 8. Okay, next thing I need to do is I just have to make sure that everything's cool with my program. So I've got to verify this program here. So similar to the Tweedo Suite, we are looking for something that has like a check mark or something. So let's go along here. Oh yes, look at this. Verify the project. Okay, so let's click this guy. Very nice. Verify has completed, no errors found. That's always nice. So we're ready to rock and roll. So next thing we're going to do is we're going to go up to here. We're going to click on this guy, and we're going to download this to our PLC. We already have our RSLinx rock and rolling. I'm going to call this guy 3-wire because I have one saved already, but this is identical. So I'm going to save this guy. Yeah, I know. Okay, and then we just hit yes a number of times. It's in the run mode. Must we switch to remote program? Yeah, sure, no problem. Change back to run mode. Yes. Want to go online? Yes. Right on. Okay, so now sometimes you'll do those things and it will be set in, it'll be offline, right? So it'll be offline like this, or it'll say remote program. So you got to go through all those different steps there. Where's that remote program? Let's see if this brings it up. Yeah, so it'll say this, remote program. And you're like, I don't understand, nothing's changing on the PLC when I hit these push buttons. You have to make sure that you're in run mode, and some of your PLC programs will not automatically go to run mode. So go to run, and then anything that you change on the screen will be seen by the PLC, and anything that you change with your hardwired inputs and outputs will change as well. So now we're ready to rock and roll. And if I hit this stop push button, then you can see that it's changing real time. So you can see right here that this guy is changing. Beautiful. And when I hit this start push button right here, it will go green. The entire run will be true, and the motor contactor should turn on. Oh, very nice. So you heard that turn on. I'm going to let go of the start push button, and we have that holding contact that has pulled in. We have another path of logic that goes to our output number 9 for the motor contactor, and we're waiting until somebody hits the stop push button to stop it, or if I put it back into run mode, then the other thing that can kick this out is the overload. So I'm going to open up my window on the overload. I'm going to grab a control screwdriver here, and I'm just going to switch the test button over. And that has just simulated that I've gone into an overload, and that kicks out my contactor and also sends a signal into the PLC to turn off my output as well. Okay, so just so you can see everything happening on the PLC as well, you can see there that my stop push button is on input 0. I'm going to hit the stop push button, which will stop the 24 volts going to that input there. So you can see all of my input terminals along the top here. Okay, so when I hit this stop push button, that 0 light will go out. There we go. I'll let go of the stop push button and 24 volts will be applied again. I'm now going to hit the start push button. That will turn on input number 1. Okay, so you can see input number 1 turned on right there. Excellent. I'm going to let it go. And it goes off. So you can see my input number 1 changing there. Okay, I'm going to toggle my overload now. So I'm going to reset the overload. And the 7 now disappeared. So again, if you missed that, let me just use my screwdriver and toggle the overload. Number 7 turns on when I have an overload state. So I now have 24 volts to input number 7. I'm going to reset the overload and the 7 LED will go out. Excellent. Okay, in addition to that, I have a normally open contact on my motor starter. So when I press that, you can see my input 5 come in. And all I'm doing is I'm literally pressing down on the coil and simulating that the coil has actually turned on. Beautiful. Okay, let me go online and I will start the PLC by hitting this start push button. And when I hit the start push button, now that my overload is reset, my motor contactor should turn on. Beautiful. You can see that output number 9 has now illuminated. I'm going to let go of my start push button. And output number 9 stays on until I hit the stop push button and turn it off. Okay, so a lot of diagnostics can be done on the screen and from these LEDs on the Allen Bradley as well. Let me just pan out so you can see exactly what I'm doing, and then we'll finish the video. Okay, so last thing to show you, I'll hit the, again, if I just pan up here, you can see that the push buttons are up here, but trying to get everything into the same shot is I can't get everything in. So I'm just going to show you the PLC program, and then we will look at the PLC and the contactors below as I hit those push buttons. So hitting the stop push button, you can just see that the LED, we've seen that earlier, that the LED is changing. I'm going to hit the start. That sends a signal to my contactor. So my contactor has now pulled in, and I can hit the stop to stop it. The other thing I can do, once it has pulled in, I can open up that window there and I can trip the overload. So I can open this up here, and I can, this little test button right here, I can move to the side, and by doing that I can simulate an overload condition. At that point you can hear that the contactor just pulled out. You can see on the screen there that my motor contactor output number 9 has now turned off as well. And it will stay in that position, and so you can see I'm hitting the start push button. It doesn't turn on my contactor. And the only way to turn that back on is to reset the overload. So now my overload is true, and now I can hit my start push button and get a rock and roll in. Excellent. All right, guys, so we kind of rocked through that one, but we've covered the 3-wire. We've shown how to put in our XICs and XIOs on the Allen Bradley Micrologix 1200. We've also seen how to set up our RSLinx and how to do our I/O configuration. Again, everything that we just set up did not make use of those analog inputs and outputs, but we still have to tell the program that they're still there while we do our analog I/O. All right, guys, thanks for your patience. We'll see you on the next video.